So we'll solve a few problems on economic load dispatch. And before going further, have a small recap. Ma'am, shall I continue? I think the strength is very low. So coming to the recap, in the last class we have seen it is basically a quadratic curve. Some textbooks it is represented as half a. This is cost. This is incremental cost. So these two are common equations which we do find in economic load dispatch problem. The first one is considered as a cost equation. The second one is considered as an incremental cost equation, where C represents a cost of generation at plant number I, and Pi represents a power generated at plant number I. Now, coming to the curves. This is cost curve. This is incremental cost curve. And target of ELD is minimize total cost of generation subjected to constraints. Now I am considering ELD without losses. Case A, ELD without losses. So my target is minimize total cost. Now CI represents the cost at each plant. So if there are n plants, sigma CI subjected to my constraints. This is the constraint, this is my condition. The sum of all my generations must be equal to my demand because I have neglected the losses. The other one is my total cost must be minimized. We have tried to solve this problem in the last class. And what was our equation? The incremental cost of all the plants must be same. This was the condition which we have obtained in the last class. The condition for ELD without losses. Incremental cost of all the plants must be the same. This is what we have discussed in the last. Now we will try to apply this particular condition for finding out an efficient problem of for solving of ELD without losses. I hope you have got your calculus. Why the strength is very low today? Yeah, are you there? How many of you are ready to solve the problem? Let's try it out. 7. Good number. Fine. Let's start. Okay. I hope you are able to see the problem. See, the cost characteristics of two plants are given with this equation C1 and C2. They represent the cost characteristics of two plants, where P1 and P2 are the generations at the two plants. Determine the economic generation schedule at each plant if the total load is 500 megawatts. So, considering these two cost characteristics, we need to provide separate generation or the generation level at each plant, subjected to the total demand is 500 megawatts. Now, in the last class, we have tried to solve two problems. Now, let the two plants have generations of P1 and P2. Okay, the generations are already given, right? So, given the two plants have generation capacities of P1 and P2. So, what is your constraints? Your total generation must be equal to your demand, and your demand is given as 500. And what is your total generation? P1 plus P2. So, I am trying to this equation. P1 plus P2 is equal to 500. This is equation number 1. And second condition, what is the condition for ELD? Condition for ELD without losses, that IC1 must be equal to IC2 up to IC. I do have only two plants here, so I am considering only IC1 is equal to IC2. Incremental cost at plant 1 is equal to incremental cost at plant. See, cost is given, differentiated with respect to its generation. You will get incremental cost. IC1 is equal to DC1 by DP1. IC2 is equal to DC2 by DP2. So differentiating with respect to P1, I am getting (0.02) P1 square is equal plus 2 is equal to here 0.03 P2 plus 1. So this is my equation number 2. Solving 1 and 2, what is my answer?
P1 is 280, sir. P1 is 280. 280.
Okay. So
P2 is 220.
220.
220 megawatts. Fine. So these are the solving 1 and 2. I am getting P1 is equal to 280, P2 is equal to 220. Now, incremental cost is equal to incremental cost is going to be the same for both of the plants. That is what is our conditions. But anyhow, we will be computing it. See, this is incremental cost of first plant. This is incremental cost of second plant. Both will be getting the same. So if I substitute it here, so what is the answer? Incremental cost is what is incremental cost, guys? Anyway, this is incremental cost, right? Either you go with the first plant or second plant, both you will get the same value. So substitute P1 and P2 here. What is the answer which you are getting? Anybody? Chandra?
7.6, sir.
7.6. And don't forget to write the better per hour. Demand is in megawatts, so incremental cost will be rupees per megawatt hour. Rupees per megawatt. So this is incremental cost, which means that both the plants, in order to have an economic load dispatch, both plants are supposed to operate at an incremental cost of 7.6 rupees per megawatt hour, with plant 1 delivering 280 megawatts and 2 delivering 220 megawatts. Do remember the final figure. For a load of 500 megawatts, the economic schedule is that both the plants have to operate at an incremental cost of 7.6 rupees per megawatt hour, with plant 1 giving 280 megawatts, plant 2 at 220 megawatts respectively. I hope you have got the answer and how to write it. Now, we have obtained the economic generation schedule, isn't it? Plant 1 is supposed to give 280 megawatts, plant 2 is supposed to give 220 megawatts, and the incremental cost must be 7.6 rupees per megawatt, isn't it? Now, the question is, what is the total cost of generation now? Can anybody compute what is the total cost of generation now? Or total cost of generation is C1 plus C2, isn't it? C1 is already in terms of P1, which you know already. C2 is in terms of P2, which is 220 megawatts. Can somebody calculate the total cost? Shall I write it here, guys? C1 plus C2. What is C1? This one, isn't it? Substitute P1 is equal to 280. What do you want to get? 0.01280 square plus 280 plus 50. P2 is 0.015 220 square plus 1 into 220 plus 40. So what is the total cost? Is everybody doing the problem?
2380, sir.
So it is going to be 2380 rupees. Rupees 2380 per hour. Rupees 2380 per hour. This is the total cost if I go with the economic schedule. Otherwise, if I divide the load equally, instead of doing all this process, let us suppose if I do have two clients, if I divide the load equally, such that P1 is equal to 250, P2 is also 250. So then what is the cost in this case? Can anybody compute for me? If I divide the load equally, instead of doing all this, if P1 and P2 both are 250, can anybody say me what is the total cost of damage? Anybody? How many of you are doing the problem? Just raise your hands. 1, 2, 3, 4. So what is the answer? If the load is shared equally.
Triple to 1.
2402.5.
2402.1. Sure. The number. 2402.1. Huh?
0.5, sir.
2.5, sir.
2402.5. So what is your savings? The savings is 2402.5 minus 2380. So what is the saving? Can anybody compute for me? It is 22.5 rupees per hour. Isn't it? What's the number? 22.5 rupees per hour. Isn't it?
Yes, sir.
Sir.
Competitive examinations, they will do the simple thing. What they will ask is determine the daily savings. Most of the students, they get confused and they will write it what is the savings with 22.5, but they will forget this word daily or monthly or yearly. So they will mention that small word here, daily or monthly or yearly. So if I consider for a daily saving, so if it is a daily saving, for a day automatically how many hours I will be getting? 24 hours I will be getting. So you are supposed to multiply it with 24. So 22.5 rupees per hour into 24. What is the value?
540.
540.
Rupees 540. That this is the answer. So what is the problem? They will mention here. Determine the daily savings. Determine the daily savings when the load is scheduled through ELD instead of equal sharing. So this will be the question for you. Determine the daily savings when the load is scheduled through ELD instead of equal sharing. This is equal sharing. What you have got 2402.5. This is ELD. So what is the saving? per day because they have mentioned daily. I hope you have now understood how to do the problem. They may ask in competitive examinations any of these things. They may ask the generation of the two plants. We will close it here itself. They may ask incremental cost. They ask incremental cost. Then this is the end of the problem. If they ask what is the total cost of generation, this is the end. If they ask savings per day per hour, this is the end. And if they ask daily savings, then we are supposed to go up to here. Shall we go to one more problem? Shall we solve one more?
Yes, sir.
How many of you are understood solving this particular problem? Can anybody raise your hands? How many of you can solve the problem now on your own? 4. Only 4? 5? ఇంకోసారి చెప్తే చేస్తామనే వాళ్ళు ఎంతమంది ఉన్నారు? ఒకసారి చేతులు ఎత్తండి. ఇంకోసారి చెప్తే చేస్తామనే వాళ్ళు. That's it. Okay, fine. So let's come back to problem again. For those who have already understood, try to practice the problem. The cost characteristics of two plants are given below. This is the problem. Kindly go through the problem. There are two plants for which the cost characteristics have been given. The cost characteristics of two plants are given below, C1 and C2 in rupees per hour. Determine the daily savings when generation is scheduled through ELD instead of equal sharing for a load of 500 megawatts. Ignore the losses. First of all, let's go with ELD. ELD without losses. First of all, determining what is the generation with ELD without losses. Our problem is determining P1 and P2 using ELD. For ELD. For economic load. So we need to solve two equations. The first equation is sum of all generations, because P1 and P2 are the two generations of two plants. Sum of all generations is equal to 500, the total demand. Equation number 1. Sigma Pi is equal to P2. Sigma Pi is two generations, P1 plus P2 is equal to demand is 500. So this is equation number 1. Second equation, IC1 is equal to IC, because neglecting losses, incremental cost must be same for all the plants. IC1 is equal to IC. What is IC1? Differentiate with respect to P1, 0.4 P1 plus 4. This will become 0.4 P1 plus 4 plus 0. This is IC. IC2 is, this is P2 plus 8. This is equation number 1. This is equation number 2. Okay. Now, solving one. So equation number 1 is P1 plus P2 is equal to 500. Now, rearrange this equation, you will get P1 minus P2 is equal to 100. Okay, so which means that P1 is equal to am I right? Anybody has solved the problem?
Yes, sir. It is correct, sir.
366 and 133, isn't it?
Yes, sir.
So now what is the total cost? C1 plus C2. What is C1? It is in terms of this one, this is in terms of this one. C. Substituting P1 and P2 in C1 and C. Substituting is total cost. This is ELD. This is ELD. And equal sharing equal sharing is problem. We don't need to solve all these things. We can directly share the load equally. Total load is 500. So P1 is equal to P2 is equal to 5. Here also you compute C. You compute C here. P1, P2 and evaluate response substitute diagram. Here P1, P2 evaluate response substitute. P1, P2 రెండింటికి సగం సగం ఇచ్చాను. Total 500 కదా. Equal sharing లో I have divided into 2 halves. So you compute this C and this C. And you say me what is the savings in my. So what is my savings? This cost minus this cost. It will be in rupees per hour. If I want daily savings, I have to multiply this one into 24 hours. Because per day I have 24 hours. So can somebody compute the C here and C here for me? What is the cost in first case?
$6,006.07.
Answer Japan, right? 6,000?
6,006.4. 6,006.4.
6,006.4. Everybody okay with this? 6,006.4. This is case 1. For case 2, Case 2, what is the answer?
Six, 825.
6825 rupees per hour. So this is 6006.4, this is 6825. So what is the difference? What is the saving, guys? $818.6, isn't it? Am I sure? Is everybody sure about these values? Correct number is 6825. Anybody acknowledge?
Yes, sir.
So the savings is the difference between these two, 818.6. Per day కావాలంటే into 24 వేస్తారు. Into 24 అంటే ఎంత వస్తుంది? Anybody doing it?
19,646.
This is going to be the savings. Sorry. This is going to be nearly 20,000 rupees saving per day. I go with ELD instead of equal share. I hope you have understood now how to solve the problem. Now, one last time, anybody who is, I hope everybody has understood the problem. Can I know the final form? How many of you are ready to do the problem? How many of you can do the problem now? Only 6 members. Only 6 can solve the problem now. 7. Right. So, for those who can solve the problem, now we will take a small problem on this was asked in GATE 2021 recently. Just 1 month back in GATE 2021, there was a similar problem asked for 2 months. Let's see how to solve that problem. The question will be a gigantic one. For those who are cracking GATE examination, once again I am reminding you, the questions will look so big. Now let's see how easy it is. Two generators have cost functions. F1 and F2. Their incremental characteristics are okay. The question is block operation determine the values of P1 and P2. So I hope you have understood that. He has directly given you incremental cost. We need not to derive it again and again. Directly given you incremental. And it says that two generators having cost functions F1 and F2, their incremental characteristics are directly given for us. They need to deliver a load of 260 megawatts. Ignoring the network losses, determine economic operation. Sorry, using economic operation, determine P1 and P2. Let's see how many of you are going to crack this problem within 30 seconds. Shall I go or will you do? Observe problem face on let me see the numbers exist. Oops. Come on, guys. What is the answer? Ratu, Kushal, Gayatri. Gayatri is also there. G1.
P1 160, P2 100.
P1 is 160.
P2 is 100.
What will be the IC here? Incremental cost. Either use this equation or this equation. In economic load dispatch, both will be the same. IC1 is equal to IC.
72.
Right. Matter of 2 months. If you see it with the differential equations, everybody is going to leave these problems, right? But if you can carefully practice it, you can easily crack gate examination. In PSOC, there are already 3 months. In this one, we have about 2 months. In 5 months in just one course, with just only 2 years. And your qualifying mark is just 30. Now, one more problem. I hope you are ready to solve one more problem. I will. Point 8 P1 plus 120, 10 P2 plus 150, where P1 and P2 are the outputs of the 2 units in megawatts. Yeah. See the question. Determine the daily loss. Determine the daily loss if the two units are loaded equally. If the two units are loaded equally, instead of optimum allocation for a load of 150 megawatts. 150 megawatts. Now, come on. Solve this problem, guys. One last call for all of you. Still anybody who wants a detailed solution? Stage your hands. How to solve these type of problems? That was just no problem. Vishal, Jeevan.
Yes, sir.
See, first of all, we are supposed to consider two cases. One is two units are loaded equally. The other one is optimum allocation. Here I will go with optimum allocation, what I call it as ELD, without losses. And here equal state. First of all, ELD. For getting ELD, I need to solve two equations. P1 plus P2 is equal to total load is 150. The other equation is IC1 is equal to IC. This is IC1, this is IC2 because alternate derivatives are being given. Equating these two, this is equation 1, this is equation 2. So, what is P1? Anybody?
P1 is 100
P1 is equal to 100 and P2 is equal to 50.
50.
Costs are being directly not given for you. On our bit. Cost related and direct cost పెట్టుకునేవాళ్ళు. Cost ఇవ్వలేదు. IC1 ఇచ్చారు. దీన్ని ఇంటిగ్రేట్ చేస్తే కాస్ట్ వస్తుంది. ఓకేనా? దీన్ని ఇంటిగ్రేట్ చేస్తే C1 వస్తుంది. దీని ఇంటిగ్రేషన్ can anybody say? What is the integration of this one? Shall I write here with the blue one? What is the integration of this one? C1 is equal to integration. 0.4 P1 square plus 120 P1 plus some constant C1. For this one, 0.5 P2 square plus 150 P2 plus C2. C1, C2 is some constant terms. Some K and code. Condition like K1 and K2. Where K1 and K2 are some constant terms. Now, to substitute P1 and P2 in these equations, you will get total cost. C is equal to C1 plus C2. Substitute P1 is equal to 100 and P2 is equal to, you will get total costs. Finally, K1 plus K2 అనుకుంటుంది. అలాంటి వాల్యూస్ అట్లే ఉన్నాయి కదా. సో ఎంత వచ్చింది ఒకసారి చెప్పండి. In this case, Equal sharing law. P1, P2 రెండింటికి సగం సగం. Half of. Both will be loaded equally. Each one having a half load. So what is total now? Again, C1 plus C2. And each of these P1 and P2 being 70. ఇక్కడ కూడా లాస్ట్ K1 plus K2. What is the first one answer? What is the second one answer? Economic load dispatch and equal share. Any question? Everybody solve it?
For without losses, it is 24750.
This is the answer. 24750.
Yes, sir.
Without loss. For equal sharing. That's none. Datu, are you there? Vishal,
Yes, sir.
what is the answer?
For equal share, it is 25312.5.
0.312.5. Very good. Rupees per hour. So what is the loss now? Subtract these two. ఇది వాడితేనేమో savings అవుతుంది. ఇది వాడితేనేమో loss. So I'll assume that this is been operating, and so I will be operating at a loss. What is the difference between these two? ఇది 2531 అమ్మా.
Yes, sir. 25312.5.
So what is the difference here? Sorry. This is the difference per hour. 562.5. And if I consider a daily loss, I'll multiply it with 24. Somebody 562.5 into 24.
13,500.
So how many of you can solve these problems? How many of you can track these problems in competitive examinations? How many of you can solve these problems? 1, 2, 3, 4. Good. Here number. Fine. 10 మంది ఉన్న క్లాస్ వెళ్ళాలి. ఎక్కువ మంది కూడా వస్తున్నారు. Fine. Thank you guys. Tomorrow, traffic, it will continue a little bit complex problems. By EST and engineering services and complex problems at okay, and real time problems. There are other losses. Tomorrow also, we'll continue with the problems. I request all of you, please get your calculus tomorrow because we will be doing a little bit complex problems. So once again, I request you to get your calculus, if possible, get your graph sheets. Okay. Thank you all.